Alright, so today with our combining functions, we're just going to look at the four main operations. So, sum, difference, product, and quotient. Adding, subtracting, multiplying, dividing. Hopefully you are familiar with those four terms. So we're going to be looking at combining two functions together. So for our sum, that means f plus g of x. So f is a function of x, g is a function of x, and we want to add the two functions together. And the way we do that is we just take f of x and we add it with g of x. And this will all make more sense when we actually do an example. Alright, then we have the difference. So our difference would be f minus g of x. So we're going to subtract function g away from function f. And for that, you just take function f of x, and then you subtract function g of x. And then we have the product, which is multiplication. So you will see an f and a g just written side by side like that. So that is function f being multiplied by function g. And to do that, you take function f of x, and then you multiply it by function g of x. And then we take our quotient. So f divided by g of x means you take function f of x and you divide it by function g of x. But here is the one part about this that gets a little bit tricky for some people. When g of x does not equal 0. And I'm going to highlight that, and I know there are some of you who like to do that in your notes. So, when we do division, if you recall from first semester, division by 0 is undefined. Right? To divide means to multiply by the reciprocal, and the number 0 doesn't have a reciprocal. So division by 0 is undefined. In fact, if I take a calculator and I press 5 divided by 0 on my calculator says error, divide by 0, because division by 0 is undefined. So when I have function g by itself, the domain for function g might be all real numbers, because function g by itself is just there. But if I'm dividing by function g, then I have to limit or restrict my domain. And I have to not include any times where this function is equal to 0. So we call this, when we state this, we call this restricting the domain. Restricting the domain. And you just have to remember that that's a part of what you have to do when you divide two functions. Alright, so we're going to do an example together where we have function p of x is equal to 1 minus 5x squared. And we're going to have function r of x being equal to 2 minus x. And we're going to go through all four of these combinations. So let's start with the sum, p plus r of x. Well, all that means to do is to take function p, which is 1 minus 5x squared, and then add that with function r, which is 2 minus x. And then you're just going to combine your like terms, and we're going to write things in descending order of degrees. So the highest exponent, the term with the highest exponent will go first. So it'll be minus 5x squared, then minus x, and then we'll combine our plus 2 and our 1 and get plus 3, and that's our answer. And what this means here is if I took a number for x, let's say the number 10, and I plugged the 10 in here and evaluated it, I would get the same answer if I plugged the 10 in here and then separately plugged the 10 in here and added those two together. Alright, so let's do subtraction. P minus R of x. Take function P, 1 minus 5x squared, and then subtract function R. Now, if I'm going to subtract function R, I must put function R in parentheses because I am taking away the 2 minus x. And if I don't put the parentheses, it'll just look like I'm only taking away the 2. But I have to take away the whole function. So in addition, the parentheses are not important, but in subtraction, they are critical. So the first thing I'll do is distribute the negative, and I'll get 1 minus 5x squared minus 2 plus x, and then I will write that in descending order, negative 5x squared plus x minus 1. Okay, P plus R came out to this. What if I did R plus P? It'd be the same thing, right? Because I'd just be adding these two. They'd just be in a different order. No worries. P minus R came out to this answer. What if I did R minus P? Would that be the same? No. Subtraction is not commutative. So, order matters on subtraction. Alright, let's do the multiplication. So PR of x would mean to take 1 minus 5x squared, that function, and multiply it by 2 minus x, the other function. So to do this, we're going to distribute. 1 times 2 is 2. 1 times negative x is negative x. Negative 5x squared multiplied by 2 is negative 10x squared. Negative 5x squared multiplied by negative x is going to be positive 5x cubed. And so then I'm going to write that in descending order. Don't have any like terms to combine. So there's my product. Alright, now to the division. P divided by R of x. So I take P, 1 minus 5x squared, divided by R, 2 minus x. So, function R by itself is 2 minus x. You see that's a linear function, right? It's a line. The slope is negative 1. The y-intercept is 2. It's a line. It's continuous. Its domain is negative infinity to positive infinity. There's no interruptions, no discontinuity. But when this becomes the denominator, then we cannot divide by 0. So before I do anything else, I'm going to set my denominator not equal to 0. So 2 minus x cannot equal 0. So subtracting 2 from both sides, negative x cannot equal negative 2. Then dividing both sides by negative 1, x cannot equal 2. So that is my domain restriction. Now, what about the actual dividing part? Well, when we're dividing, we would want to look to see if we could factor the numerator or factor the denominator. In this particular problem, we cannot. There is nothing that can factor and divide out. So this is my answer, along with this domain restriction. So the domain restriction is part of your response in division. Alright, so now I'm going to give you two different functions, and you're going to practice each one. If you're listening to this video, I want you to write these down, and then I want you to turn the video off and try these for yourself. So we're going to have f of x is equal to x squared plus x, and g of x is equal to 9x. And so then you're going to do f plus g of x, you're going to do f minus g of x, you're going to do f times g of x, and we're going to do f divided by g of x. Alright, so I want you to work with a partner on these, right? This is practice work. When we get to iExcel, it's going to be all lonely time, so right now, have talking time, talk these out with a partner.
First three of these,
yeah, I already did the first two. What she was talking about. But back Alright. I mean, the first one, the only combining you have to do is you do the 9x plus the x, so you get x squared plus 10x. Yeah, the answer would be x squared minus 8x, because you just combine the x and the 10x. And then for the multiplication one, I got 9x cubed plus 9x squared.
You always put them we can realize individual functions. You don't put the function inside the other function. Here's minus.
Oh yeah, you got your license. to us because I can't see that.
You know, whenever I did it, I like messed up.
They only asked me to read like the first few lines, like the top.
Yeah. Yeah, after I got my license, like a few months later, I got classes. Okay, alright, what did y'all get for the last one? Basically the same.
X times x plus 1 over 9, and then the domain restriction is x 9. But
Wait,
I don't know what I did. I kind of just did stuff. I don't remember how to really do division that well.
Okay, so I think that I could be totally wrong, but I think that we would do like those two x's would divide out or something. Or well, maybe not because I'm not sure. That's what I did now. What'd you do?
I got 9x cubed plus 9x
I don't know.
I think if there's
It went good. We did finals, but we did not make it to state. Regional prelims, we passed it, and then we went to regional finals. And then one of our swimmers did make it to state, and she's so good. Yeah, she's really good. She's been swimming since she was like a child. So, but yeah, I want to go to state next year. That's my plan. I already joined other swimming, so yeah, actually, I think I can do it. I honestly do. Let's see for what event. I don't know about that. I mean, she hasn't told me that she wants to go to the Olympics. She just has always done swimming and she loves to do it. And she's really good. Yeah, you might. Like, if you want to go to the Olympics, you gotta go through club swimming. And then they have like the same process of like district, regional, state, just different names. And then you can go to Junior Olympics. And then after that, if you pass the Junior Olympics, you go to Olympic club. And so it's like a lot of that. And then for Olympic trials, you have to swim 6 times, just course of 2 weeks. And every single time you have to like do the best you can to qualify for the actual Olympics. Sounds like fun. I mean, yeah. It's just part of the sport. It's a very like intense sport. Very tiring.
I guess I saw like they did this and this like Is that
Yeah.
All right, so let's come back together. All right, so if you're watching this on video, pause and try these on your own. Okay, so for the adding, you should get x squared plus 10x. We good? Subtracting, x squared minus 8x. Multiplication, 9x cubed plus 9x squared. All right, then we've got the division. So on the dividing, you're going to set it up, x squared plus x divided by 9x. The first thing you're going to do is identify your domain restriction. So you're going to say 9x, the denominator, cannot equal 0. And then if you were to divide both of these sides by 9, you would get x cannot equal 0. Because 0 divided by 9 is 0. You can divide into 0, but you can't divide by 0. So there's our domain restriction. But now there can actually be some division that happens here. So what you want to do is you want to factor out your numerator. So your numerator would factor into x times x plus 1. So we have got a common factor of x, so we factor that x out. It's like undistributing. And then I'm going to write my denominator as 9 times x, right? Just to make it very clear that I've got two factors here. I've got multiplication happening, and then I've got two factors here. So when I'm multiplying, I can divide out a common factor. So x divided by x is 1. Because we really don't want to just get into canceling, right? You might even see that what I'm doing is I'm dividing by x and dividing by x. So if I take this and I divide by x, I get x plus 1. I take 9x and divide it by x, I get 9, right? So what I'm doing here is I'm dividing the common factor out. And it's okay for me to do division because these are factors. They're multiplying together. So again, try and break away from that whole idea of canceling. And so our solution would be written as x plus 1 over 9 for x not equal to 0. Now, a different way to say this could go like this. X plus 1 divided by 9, and our domain would be the interval from negative infinity to 0 with a parentheses, not a bracket, because we're not going to count 0. Union with 0 to infinity, no bracket here. Do you see that what this is saying is this is saying all real numbers up to 0 and then all real numbers after 0, but since there's no bracket, we're not counting 0? That's another way to write your domain restriction.